Hello. So there's a current problem I'm facing and trying to work through. And currently I'm developing an essay grading sort of application. I've tested something that I've been working on, but I always seem to run up into a few problems, and today I'm going to kind of discuss those. So the goal in my task has been to build an automated grading system. And ultimately, this system will be able to recognize and respond to written human communication and then evaluate it with near human ability. So I don't know, I was misspelling there. So near human ability. Current limitations. So I've talked a little about that. Let's talk about the current abilities. So this regression using regex and a combination with Python to evaluate features of written text. Okay, so right now we can evaluate text and we can give it some idea of the grammatical features, I should say. Grammatical features. That would include noun phrases, etc., with a degree of accuracy. So there's some accuracy here, but it's not perfect by any means. And with regex, you can also do some basic search and find whether patterns appear, and basic patterns appear in the text. So this is a nice feature, and what it allows you to do is find just some sort of common problems and patterns that show up. Also, I've been getting a lot better at regex, and that has in turn allowed me to find even more complex searches rather than just doing a simple in search in Python. Unfortunately, there's still limitations to this approach and stuff I'm currently working through. This regression or regex approach is all too inflexible. And even if you were to scale it up, what would that mean is it cannot respond to all types of human writing, nor does it do a good job of evaluating the differences evaluating a dialect-free human speech, which is not in itself a terrible, but the fact that it's so limited would mean you need thousands and thousands of these regression patterns to meaningfully evaluate a text anywhere close to what the human can do. It also requires inter-sentence, so that means between sentences, bridging to construct meaning. So you need this complex system of inter-sentence bridges, sentence connecting to another sentence, noun phrases connecting to their antecedents to really figure out if they're properly connecting. And the language often doesn't give us that either. So what are some other options? This approach it's a more challenging approach, we should say. So what are some other options? Well, you can use machine learning to evaluate features of the human language. Okay, so by machine learning, you can use various algorithms which parse language and deploy it into discrete parts. And Stanford University has a great implementation of this. You can go already and see sort of sentence diagramming drawn for various sentences. And it's just great to see how it breaks it down into subject and object parts. And generally, this is a pretty good approach, but unfortunately, this is often clunky, but not terribly fast. In fact, terribly slow. Clunky and can be slow. Another thing we could do is currently there's an NLTK language parser, although I've had quite a few issues with trying to use this one, and pattern.n, which does the same thing as a machine learning algorithm, the one I mentioned described by Stanford University. But pattern.n does it, however, it's only about 70 or so, well, I wouldn't want to say that. It claims to be up to 80% effective, maybe even higher than that, but I still find that it has problems with multiple verbs in English that look just like nouns, so it's not the ideal choice either. And it can do discrete features of the human language when the language is in the proper context and in the meaning that it's intending. the grammar it creates when the language has grammatical errors in it can be buggy at best. Okay, so those are the current limitations, and there's no real good system out right now that can handle all of those. So what my goal would be is ultimately to build a grading system. That's what I hope to do, and that's what I've been trying to do. And what you would do is you would feed in an essay, and it would evaluate it. It would give it sort of a score. A score, some sort of score that can be objectively measured. Then it would return to the user and the graded progress with changes in it, with suggested changes. So you would send back an HTML or even any kind of file with comments and strike through, or just sort of removed, and remove text. That's the idea anyways. Now how exactly you remove the text can be something you talk about later. So the way that I've started to go about this is there's a few things that are kind of low-hanging fruit, in other words, to try and solve this problem. First, using pattern recognition. Regex is what it's called in Python, some other processors, some other programs. So you can use regex as a system to try and do pattern matching. Okay, what would you do? You would try and detect transitional words that begin sentences, such as, for example. So you would look for this, you would see, okay, is it the start of a sentence? Check that, make sure you have, for example, and make sure it ends with a comma. If all of those features are in place, then you would say, good job, you have used a transitional word. The problem, of course, is, well, there are a lot of variables you have to consider. For instance, if that person removes the comma, you have to design kind of another system to go about asking the person, do you want that? You should include that comma, while should you still accept it? But regardless, you can detect transitional words and evaluate them appropriately. The next thing, you can remove problematic statements like I think, or will you pay, idiomatic problems, like it should be you will pay for it, not of. So you can remove of and insert for. You could also, easily find missing punctuation. Find repeated words. So word choice or repeated words. You could find words like thing. Often my students will say thing, or any variation, thing, if they mistype it, and etc. And you can find this and assign it a score and remove that. You could also evaluate some spelling errors and any dangling modifiers or even passive statements. Although some passive statements, of course, sometimes it looks passive, but it's you have to be careful. It's not in all cases, but most of the time you can find that. Okay, those are sort of the low-hanging fruit that I've been able to sort of to use and evaluate, and also I should say this is kind of it's meaningful. Word count. So basically, just counting how many words there are. That's a really simple task that you can do. That would help in the grading. So any of these formatting features, word counting, punctuation, and even to some degree, like I said, spelling errors can be reasonably detected with the current system out. But the deeper problems, that includes human language and communication as a function of not only physical, but other kinds of relationships, just human relationships. It's tricky to find out if to build a matrix of meaning where physical or human relationships can be mapped onto human language and expression. And not only that, finding the human expressions kind of can relate to each other, and building a matrix or building some sort of associative system where you can check the two against each other. Multiple meanings can be associated with any given sentence. That's another deeper issue, is that it really does depend on an understanding of the whole to figure out what that sentence is. And although this isn't an insurmountable problem, this is really a problem of scale. So how do you do this in an efficient, effective way? when you have kind of limited resources. So, and finally, a semantic parser must be able to build detailed map of relationships within the paragraph. So, sentence relationships. And I don't think, this is where I think the current machine learning, at least the ones that I've used, have more or less fallen short. They don't have a good sentence, intra-sentence analyzer. So they need to be able to effectively identify one sentence in its relationship to the other. If we could get to that point, I think eventually we could be able to bridge out and build the paragraph analyzer. But really, this would be a huge step. If we could get the intra-sentence analyzer to any degree of efficiency, that would really be a huge step in this area. So what about a hybrid approach? Well, what I've thought about doing right now is building a system where it flags problems, and then you have a matrix. Basically, a human reader will evaluate problematic sentences and then assign them, to get assigned, to a matrix of patterns. So these patterns will build up over time, and over time you will have just a large build of pattern recognitions. Of course, this is also potentially long. The advantage, though, is even though, let's say, you had 100,000 sentences like this, if you build it this way, then it's a problem of accessing. It can be done from the server, or it can be done, locally. But the problem is, in this way, actually a little bit more feasible, a little bit more workable. Because although you have a potentially long list here, maybe you can break it up, you could combine some, you could eventually do some sort of refactoring to get those sentences, to get them shorter and to make it easier to access. So this is an actual step that I'm thinking maybe I could do in the future. Just build a long list and see where that takes us. It's sort of a naive approach, but I mean, we'll see how well it goes. And then over time, this matrix will evaluate troublesome sentences, and of course, large bases build up, which means it's potentially long and memory intensive. Key coding errors and feeding essays to readers. So a hybrid approach might also be to key code errors. So to assign a list of key coding, and then feeding those essays to a reader, eventually trying to analyze patterns based on tags. So use tags that users create to draw patterns and draw up a large system of patterns that can be applied to multiple essays. So limitations of this is that right now I have a really small data set. So while this seems nice, it will require, both more learning on my part and just a larger base of data to work from. So those are the current limitations. And like I said, if we could build that intra-sentence analyzer, I think that would really take us to a better step in solving this problem. I think we could get much deeper analysis and quicker for students if we could build this intra-sentence analyzer. So that's probably the next task I'll try and work on, as well as developing this flagger, because that seems pretty straightforward. Okay. Thank you guys for watching. Take care.